finally we'll have Z, which will be So this is no different from R3 by 3. Only thing is you have another row and a column. All the same principles of fixed axis, current axis, everything applies to 4 by 4. The only thing that does not apply, as I mentioned, is the inverse of H. Inverse of H is not its transpose. Yeah.
So you can also do this by rotating the y by minus 90 degrees.
Yes, that's what I said. The rotations are not unique. Okay, that means this is not the only solution that you will come up with. If I choose to align, instead of what I did here is, we choose to align Z first, right? I can choose to align X first and then go on to aligning a different axis. It does not matter, okay? The choice of the axis that you rotate is not unique. But what is unique is this. No matter what you do, you cannot come up with a different transformation matrix. If you come up with a different transformation matrix, that means I can do two transformations that will lead me to two different points in space. That is impossible, right? So the transformation, eventual transformation, this is unique. The order is not unique, this is unique. Okay? Eventual matrix that you will get is unique. For example, what I want you to try is the following, right? So let's do a different method here. Okay, so instead of going like this, we went like this. Let's try to go up, or I'm sorry, we are coming down, right? H1, 2. Let's try to come down like this. Okay? Let's try to move along this axis. To move along this axis, I want to align, let's say, X here. So I want to align X1 here. Okay, I want to align X1 here. To align X1 along that slope, what is the rotation needed?
Along the y-axis, 45.
45. Along the y-axis, 45 would
Minus 40.
Z
No,
minus 44.
no, it's
plus 45.
plus 45, yeah.
Okay, Z by 45. When you do, because this is within the board, right? So when I do Z45, the axis, these two axes will rotate like this. Okay, this will move from here like this. This will move like this. So I want to align X along this direction. So the first rotation that I need, let's do a different way, H1, 2. The first thing is rotate Y by 45 degrees. Okay. Once you rotate by 45 degrees, this is aligned here, right? So next what I'll do is, I'll translate along X by root 2. So what I'm doing is, I'm coming down along X. Now what I want to do is, I want to undo this. Okay, so we can come back to the original position of X. Okay, so what I'll do is rotate Y by minus 45. So what I've done is, I've undone this. So now I'll have two axes like this. Or you don't need to undo it. You can just continue from there on. It's up to you. But just so that we can draw it properly, I'm just going to undo it. Now here, when I undo this, this will be like so. This is Z1, Y1, and X1, right? C2.
Professor?
Yes.
Like there is a way better than other, like in terms of complexity, number of operations, or
If there is, okay, let me tell you. When you do only one rotation, right? One rotation is about one axis. So let's say I have Z, X, Y, okay? When I do a rotation here about this axis, what will happen is this will remain constant. So this will be Z1. Let's say this was Z0, right? The only difference would be this will be X1 and Y1 because they have rotated, right? Or this way or that way, it doesn't matter. So if I see that one of the axes is already aligned, that means I need only one rotation to move it back, right? In this case, none of the two axes are aligned. Any two are not aligned. So it will take more than one rotation. Because whenever you rotate about a particular axis, unless it's a fixed axis rotation, in which case all three will rotate, then you need an independent axis or a k-axis, right? In this case, so long as none of the two are aligned, that means you'll need more than one rotation to bring them into frames, okay? Overlapping frames. Otherwise, it's not going to happen. Okay, but no matter how much you do, eventual matrix that you get, which is your H matrix, this should be the same. If this is not the same, then they are oriented in a different way or you have come up with a different orientation, okay? So that is not going to change. Now the rest can be exactly the same, or if you want to avoid this, so let's say that Y was there, so, okay, so now it will be exactly the same steps that we did previously of aligning these two. What I want you to do is start with, last time we started with aligning, I think we aligned, which was the axis we aligned? What was the first rotation we did last time? X90. So let's complete this. Let's do a rotation about Z.
Is this the same one but trying to do it differently?
Yes. So we are coming down the slope instead of going like this and like this. Okay. So if I want to do a rotation by Z, I want to align Y first. Okay. So when I do like this, when I flip this like this, so I can do a rotation like this, Y90. When I do it, Y will go up and X will go within the board. So this will be Y1, Z1, and X1. Okay, so I can have this rotate 90. And finally, we need one more rotation, which is to bring Z outside. So to bring Z outside, it will be like this, negative 90 about Y. So that will be X1, Y1, and Z. Okay. So when you multiply these, you should come up with the same matrix that we came up last time. H12 should be same. Okay. Okay, so as a homework, I want you to check this out. Two things. First, verify that H12 is the same as the previous case. Okay, A. B, find. We did not do this one. We did H01. We did not do H02. Find H02. B, I'm sorry, C, verify H02 is equals to H01, H1.
Professor, do we need to find the
Next one. Okay, so you have to multiply this and check that this is same as the previous one. Second, find the translation from here to this point, okay? And finally, verify this.